I'm really glad that you've all done so incredibly well this semester. It's really impressive how much you've all progressed, and you know, in many ways beyond what I thought you could do. So yeah, bravo. Good job, everybody. Now we have to pass the final, right? We have to do that. And I'm going to go over what's going to be on the final here for you. And I'm recording this, I'll post it. As I mentioned in a previous email, the final is entirely based on the textbook. So you can actually just look in the textbook and find some of the questions that are going to be on the final. Some of them I changed around a little bit. Some of them took them, from here and there and moved them around a little, but they're most of them from the check your skills section. And this is the reading list that I sent you. I know I assigned reading throughout the semester, different weeks, different topics. And here it is pulled together in one place for you, which I realized would have been helpful at the beginning as well. But here it is now. So chapter 1 was week 2, picturing distributions with graphs. We went over chapter 17, one-way t-test. I know this seems like a little out of order, but I just really like to do a t-test before I do the regression. Then the two-way t-test, ANOVA, chi-square, correlation and regression. And then we had the midterm. We didn't have any reading assignment. And then we went on to have experimental design, chapter 7 and 8, multiple linear regression in chapter 28, which was in a different section. I sent you in a different section. It's in the resources tab. If anybody has a hard time finding any of this, just let me know. I'll point it out. And then we did chapter 26 and 27, two-way ANOVA and non-parametric tests. And then we went back to chapter 28, the second part of chapter 28. We went over logistic regression and then ordination and graphs. We didn't have a chapter for that. So that's actually not going to be on the test. I do want you to know about it. You were introduced to it, but it's pretty advanced. So I think it's okay to leave that off the final. And then you gave your project. So this is what's going to be on the test. Here's the textbook. You all have this. And if you go down to the very first section, we have the table of contents, which helps a lot, right? Here's chapter 1, picturing distributions with graphs. Chapter 1, picturing distributions with graphs. So we'll just go down to chapter 1. This is the detailed table of contents. I recommend following along with me as I do this. The introduction is really helpful as well. And remember, we went over this a lot in the very beginning of the semester. We talked a lot about graphing data and how to really see data, how to visualize data, right? Statistics is the science of data, and not just numbers, but actual data that means something in the world. So if you start at this chapter 1 and you search, check your skills, in the check your skills section, you can find these multiple choice questions. You might even remember this one from the little video I did. A study records the sex and weight in kilograms of 30 recently born bear cubs in Alaska. Which of the following statements is true? Sex and weight are both categorical variables. Sex and weight are both quantitative variables. And sex is a categorical variable and weight is a categorical variable. What do you think? How would you answer this question? Yeah, see, sex is a categorical variable, male, female, right? And weight in kilograms is a quantitative variable. This is one of the questions that might be on the test. Then we have this next question. The statistical abstract of the United States prepared for the Census Bureau provides the number of single organ transplants for the year 2010 by organ. The following two exercises are based on this table. So you just look at this table here. It has heart, lungs, kidney, pancreas, intestines, right? And it shows the number of single organ transplants. I think I also made a video on this one. And the question is, the data on single organ transplants can be displayed in a pie chart, but not a bar graph, but not a pie chart. C, either a pie chart or a bar graph. What do you think?
C.
Did you say C?
Yeah.
Okay. No. Think about it. A pie chart, you got to have the proportions of all the single organ transplants. There are other organs that could be transplanted, right? Right? Unless you have the total, you can't make a proportion, so you can't make a pie chart. So what's the right answer for this?
B.
B, right? Right. Okay, so you have to think about it a little bit. Kidney transplants represented what percent of single organ transplants in 2010? Nearly 61%, 1/6, nearly 71%, or this percent cannot be calculated from the information provided in the table. I kind of what I just said, right? You actually don't know because it doesn't include all the other organs like eyeballs or eardrums, or I don't know what else people transplant, but there are other organs people might do transplants on, and we don't have that information, so you can't calculate it from the table. And that's an important thing to think about when you're making a graph. What kind of information is the right kind of information to put into a graph? And then we look at the number of flea jumps in the histogram. Again, I think this was already in that video, so I'll skip this one so you can watch that video and you can go over that one. And I think if you want the answers to these questions, you can either read the chapter, think about it, which is what I recommend doing. Or if you're really stumped, you've read the chapter, you've looked at the question, and you think, I still don't get it, you can look up the answer online. There's this site called Quizlet that has all of the answers and explanations, and you can use that to study. I'm not going to tell you no.